Welcome to the Industrial Talk Podcast with Scott McKenzie. Scott is a passionate industry professional dedicated to transferring cutting-edge, industry-focused innovations and trends while highlighting the men and women who keep the world moving. So put on your hard hat, grab your work boots, and let's go.
All right, once again, welcome to Industrial Talk. Yes, I unmuted my mic this time around so everybody can hear me. And we are operating, we are broadcasting on site, OMG. This is Q1. We're in Reston, Virginia. And it is, again, a collection of people who are truly, they're givers. They're givers of solutions, and they really are doing what we take for granted. So that's what OMG is all about. Find out more. Go out to omg.org, seeing how you can get engaged. All right. He's been on the hot seat before. He's in the hot seat again. Chuck is in the house. We're going to be talking about AI and a lot of other things, so let's get cracking. There, it sounds better when the mic works. You know, yours work. How are you doing?
It's great. And thanks again for having me, Scott. Always a genuine pleasure talking to you. You're easy to talk to, and I think that the listeners get an excellent chuckle out of all the things we talk about.
There's an action shot coming up there, so you got to give it to you. So before we get into this conversation, because you have you're a wealth of knowledge. I always want to just curl up by the fireside and just listen to what you have to say. But nonetheless, give us a little background, just a little bit about who Chuck is.
Sure. Well, master's degree in electrical engineering. I taught the computer control and instrumentation class at the University of Wisconsin. I was a Bell Labs fellow at Alcatel-Lucent, where I invented some stuff that's probably in your pocket right now.
See? You just don't know.
It's hard to say.
Yeah.
Well, my favorite invention, little digression, is the thing that screeches at everybody when there's a tornado coming.
Shut the front door.
Yeah, based on, I have a U.S. patent on a thing that figures out where you are and alerts you to approaching badness. So I'm not sure that Alcatel-Lucent ever made a whole lot of royalties off of that. It's not the kind of thing you'd enforce, right? But I guess I feel like I've saved somebody's bacon somewhere along the line.
Son of a gun.
Yeah.
That's so cool.
So when you're sitting in one of those, meetings, conference rooms, and everybody's phone goes off at once and everybody dives for the shelter, that's my pet.
Wow.
Yeah.
See?
So anyway, I did that stuff. I worked at Cisco for 10 years on computer control instrumentation stuff, as well as lots of Internet of Things and edge computing stuff and a few drone things. And lately I've been the Chief Technical Officer of the Industry IoT Consortium, which is one of the OMG programs that just recently, in the last couple of months, has been integrated into the Digital Twin Consortium. And that makes a lot of sense. The Digital Twin Consortium is really about pairing simulation models in real time with physical systems, and then using one to sort of snowball and predict the other. The Industry IoT Consortium is really about sensors and actuators, the plumbing and the sensors and all of the computation necessary to take a look at those physical systems. And the union of those two consortia really represents a very powerful combination of having all of the technology to sense and network and actuate the physical world into the digital world, and then all the simulation stuff that uses that sensing and actuation to sort of run time out into the future and predict. And if I tweak that oil refinery a little bit, is my yield going to be better? You don't want to do that experiment on the oil refinery, but if you got all the sensors in the oil refinery telling you what the parameters are, then you run a bunch of simulations of the physical processes in that refinery, and you come back with one good answer that says turn that pressure up 14% and you'll get a better yield. That sort of thing is the sort of thing that digital twins plus the Internet of Things is going to enable us to really augment and really help us.
See, I don't know how you cannot, if you're listening out there, how you cannot be involved or engaged in an organization like OMG, because I just think that there's a velocity that exists out there within all of these systems, and the conversations are constantly, I think it's always a challenge for OMG and the staff of OMG and the people of OMG to try to wrangle these cats in a way that you produce something that is so meaningful and helpful.
Yeah, we've got an excellent track record of doing things that I think are really important to society, and as the planet gets more digitized, the stuff that we do is the fundamental nervous system of that digitization.
One of the things that has been, and I've been to a number of conferences and a broadcast from a number of conferences, and you cannot avoid the conversation that involves AI.
Yeah.
And then because it's Wild West out there when it comes to this AI stuff, nobody really knows what they might have an idea, but it's still it's the Wild West. How do you begin to sort of wrangle that bad boy in and start to create some standards, trustworthiness around all of that?
Yeah,
because I don't.
That is an ongoing challenge for sure. And the first thing you got to realize is there's lots of different flavors and degrees of AI. Machine vision is one that's not that hard to wrangle. I mean, you're looking at a bunch of pixels and you're pulling features out of them and saying, yeah, that looks like a pickup truck bashing through my front gate or not. That sort of thing is one type of AI, and it's deployed everywhere, and it's hugely useful and occasionally problematic. But the thing that I think has got the world crazy these days is what's called generative AI, using a technology called large language models. And that's basically trying to figure out what's new. What it basically does is it takes the whole internet and it kind of digests it into hundreds of billions of parameters, and then it applies them to a technical thing called a neural network, which basically you give it an input, like write me a term paper on the Russian Revolution. And what it basically does is it uses these billions, hundreds of billions of parameters to figure out what the first word ought to be, and then figure out what all the words after it follows. And if you go to ChatGPT or you go to the Microsoft 365, their Copilot stuff, you go to those, and that's basically what they're doing. Is they have a pre-trained large language model. That's what GPT means, generative pre-trained transformer. That's what that acronym stands for. And basically what you do is you figure out what the next thing ought to be, string a bunch of those together, and you end up with an answer to that term paper problem, or how do I write a Python script to do XYZ, or how do I make a picture to represent a certain thing for my next PowerPoint presentation. I've been experimenting with GTP for over a year. It came out in November.
It was like a light switch. It was there all of a sudden. It's like, oh yeah, there it is. Boom.
And I've tried some things that it's like, there's no way in heck it's going to be able to do anything about this. And it just knocked it out of the park. And then I ask it other things that ought to be simple, and it just bumbles stupidly, right?
Yeah.
And the problem is when it bumbles stupidly, it does so with exactly the same authority and fervor as it did when it gave you the best result you could have possibly imagined. So knowing the difference between those two really has to do with a couple of parameters. One is the so-called prompt engineering. Do you ask it the right question in a very deliberate, very precise way so that it won't go off any of 10,000 different tangents that it could have gone off because you didn't ring it in correctly? That's an important thing. And then the second thing is can you independently fact check it? Does the result of the generative AI pass the sniff test? And after a while, you kind of know what a bias or a hallucination result starts to look like. And then you basically do, kind of like what all those political pundits have been doing all along, is you go off and you fact check the thing. Did it hallucinate that, or is there some independent validation on the internet or elsewhere that the result sort of seems reasonable? And when we start to hook generative AI onto the Internet of Things, mission-critical and life-critical systems. So if generative AI, for example, is starting to control my reactor, my locomotive, my implantable insulin pump, those kinds of things, that's the place where a hallucination or a bias starts to kill people. And we could argue that those problems already exist in self-driving cars and all kinds of other systems, but as we start putting more and more of the Internet of Things directly into this digital twin model, where there's a sensor and a network and generative AI and a network and an actuator and a closed loop where there's no humans doing any fact checking, that's the place where we're potentially starting to look at challenges. And we've got some ideas in a newly formed AI task group across all of the OMG consortiums on ways that we might be able to at least detect when something isn't as trustworthy as it needs to be. And ideally,
how do you do that? That I don't understand, because everybody's used it, and you're absolutely right. Mm-hmm. The prompt is really the part where you start, and I'm always, it's sort of weird, because here's the thing. I'll watch somebody else do it, and I will be very keen on their prompt to see how they're writing it.
There are college courses on prompt engineering.
Yeah, see, there it is.
Yes. So to answer your question is how do you rein it in? How do you make sure that a typical or a system is behaving itself correctly? There's one answer to that, and the answer is almost as ugly as the problem, and that is what I sometimes call a meta AI. Where you have, let's say that I have a really important result that I want to use AI to get that result, and I'm going to apply that result to $1 million problem, life critical problem. What I might do is ask 3 or 4 independent AI systems, the OpenAI, the Facehugger, the Microsoft one, the Google one, ask them all to generate an answer.
But using the same prompt.
Using exactly the same prompt, but a different training corpus, right?
Yeah.
Because OpenAI is not training the same stuff that Google is. And what I can then do is use a meta AI, an engine that takes the results from those 4 AIs and tries to vote on them in some way to let off the things that don't seem like they're consistent across the multiple AIs and amplify the things that are really similar across those AIs. So the idea is that the bias and the hallucination is pre-filtered, because unless a result happens multiple times across multiple AIs, it might not be trustworthy. But if it happens in 3 of those 4 AIs sort of the same way, giving you a result that's pointing you towards the same direction, then you can probably have confidence that there wasn't a bias or hallucination that happened in the composite answer. So that would be one way that you might be able to do that.
There's a platform, I think it's called H2O.ai, and that product does the same thing. It sort of just queries multiple engines or whatever, and then sort of displays it in such a way. It doesn't say, oh yeah, everybody's sort of leaning. You still have to do that with your own eyes.
Yes.
But it does pull up. It's like, oh, okay, this one gave a lot. This one didn't give as much. I don't know why. That type of thing.
Right. And that's a step in that direction.
Yeah.
But that still has a human in the loop, and the human themselves could be biased or untrustworthy for some reason.
Yeah.
So the panacea of all this stuff is to try to figure out a way to automate it so that I can get those results in less than a second and turn around.
That's the key.
The tuning of the real-time systems. That's one of the things that the object management group is particularly strong on, is all these real-time systems that are able to do things with sensors, closing the loop of computation, and doing an actuation before the results that are causing that actuation become too stale to be useful in the physical system.
You cannot have this conversation, this computation conversation, as we, like you said, ChatGPT, year in its life, maybe a little longer, who knows, but it's exploded.
Yes.
And so there's this computation reality that if we don't address that in some way, meaningful way, then all of this is just sort of, take us through that.
Where are the compute cycles coming from?
Yeah.
Is it coming from an Amazon Web Services server room somewhere?
Yeah.
And the answer is the servers that we've been using in the big 5 cloud service providers, Google, Amazon, Facebook/Meta, Apple, and AWS, Microsoft, excuse me. Those are, they all sort of rack up these servers, 40 standard computers using Intel Core i9 kind of processors. They rack those up, and then they put in 10,000 of those racks into an acre data center, and then they pour 50 megawatts of electrical power into it, and they can do a pretty decent job at, for example, e-commerce, or trying to, maybe serve up a Netflix program for you, something like that. But if you're trying to build a generative AI model, I've got some statistics on the ChatGPT 3.5 model, the one that OpenAI debuted in November of 22, and is the one that sort of kickstarted all this. It took 3.1 times 10 to the 23rd floating point operations to train that model. And that's basically a measure of ridiculously large computing power. And what you need to do is to build an infrastructure, and that took them $48 million, I think was the quote, and about 9 months worth of computation. I think they used the Microsoft servers for that. That's a thing that is not sustainable.
No.
Because it gets ugly fast.
Yeah.
So what you have to do is get on to a better computing platform. And that today tends to be graphics processing units, the same GPUs that you see similar to the ones in your PlayStation or your Xbox 360 or in the special accelerator card that you put into your laptop PC because you want to play games. Yeah. Or maybe you've got a more sophisticated application like you want to render videos.
Yeah.
Those are what you use GPUs for. It turns out that NVIDIA in particular has pioneered a thing called GPGPU, General Purpose Graphics Processing Units, where the GPUs have some special architectural tweaks to them so that they're pretty good at managing images and rendering textures and all the things that GPUs normally do, but they're also really good at doing a whole bunch of multiply and accumulate operations, trillions of those operations, in order to start to whittle down on that 3 times 10 to the 23rd operations that are necessary to train the GPT-3 model. And I did some calculations that I can share with you about this.
Yeah, please.
It turns out that it's important to train that model kind of quickly because, I can give you an example of why. I asked ChatGPT to write me a 2-page paper on the dangers of Chinese balloons. And it wrote me this really excellent paper about heavy metal poisoning and choking hazards for babies and wildlife problems.
Whoops.
But it didn't know anything about balloons floating over Lake Erie.
That's right.
Because it was trained before that.
That's right.
So the staler you allow your training corpus to get, the lousier the results of these things will be, and the more danger you'll have of missing something really important in that trained model. So I said sort of arbitrarily, well, let's retrain those 3 times 10 to the 23rd operations in a week. Let's figure out how much computation power is necessary to do that in a week. And I can use a particular type of server, which is called an NVIDIA DGX H100 server. And it's got 8 of these big old GPUs with about 15,000 processor cores in each of them, 150,000 some processor cores. So it's 2 or 3 orders of magnitude fatter than the 1U Intel servers.
Right.
And let's just rack a bunch of those up and keep going, make some assumptions about how many of them you need to train the GTP3 model in a week. And the answer is 195 of those servers.
No kidding.
Yes. So that's, and there's a lot of footnotes on that about the efficiency. And it turns out that one of the problems with those servers is they all kind of want to talk to each other. All of the GPUs in that architecture, 8 per server times 195, they need to talk to each other because they get to a place where they've calculated all they can with the memory that they've got in that GPU, and then they got to reach out to an adjacent GPU and fetch other stuff to finish the calculation. And in the meantime, the first GPU is stalled waiting for the return of that. So if takes too much time to get that result back, then your system is likely to be less efficient. So you make assumptions about that, put it all in place. What do you think 195 of those servers costs?
Right. I can't.
It's about $80 million.
Yeah.
And it uses around 2.5 million watts of electrical power, which is the equivalent of, 10,000 houses or something like that. It's ugly fast. But the model that it creates is something that is really, really useful because it's doing the basis for a very modern, very current, high-performing generative AI system. Then once you compute the model, You spit it out to a bunch of perhaps less costly servers to do what's called the inference. That's where you give it the input from the user, the question from the locomotive, and it crunches on all those parameters in the model, and then in 20 or 30 seconds it spits you back the answer. If you have a really fast set of GPUs, like the one I was describing, instead of taking 30 seconds for it to write that term paper for you, maybe it would take 1 second to write that term paper. And that starts to become really useful in these real-time Internet of Things situations.
Yeah, but the power it's still difficult. Just that scenario that you provided still. We've just scratched the surface.
Yeah, where does the energy come from? How do you cool it? Those are all really interesting questions.
And it's just because it's going to continue to proliferate, and they're going to create more use cases to, hey, let's use it here, let's do it here, in this manufacturing process, and it's all necessary.
It's up to engineers like me to make it as efficient as possible. And the ways you make it efficient is you figure out a way to get the energy from a place that isn't going to provide a lot of carbon pollution, like renewables, generally wind or photovoltaic solar. There's a new technology called small modular reactors, back to nuclear, and those are really very promising. A 50 megawatt electrical small modular reactor, it's about the size of a mobile home, and you can sort of bury it in this little bunker out behind your data center.
That's pretty doggone.
Yeah,
that's pretty good.
And that would run quite a few of these model building engines. And what energy you don't use there, you just send to the truck stop across the street to charge all those electric semis that are going to be sitting around wondering where their energy's coming from. So there's a lot to be said about that. And then you got to figure out how to cool it. And it turns out that those GPUs want to all be sort of tightly coupled and tightly packed in with each other, because the amount of time it takes for the electrons to go out a couple of meters of cable will screw up that inter-process communication bandwidth. So if you squish more and more of them into a smaller and smaller package, you get to the point rapidly where you can't blow enough air through it to keep the thing from melting. So that means you got to take that whole server and dip it in dielectric fluid. Immersion cooling, it's called. And that's a very important trend in the next generation data centers. They're going to not use hurricanes full of air where you have to have headphones on when you go into those data centers, because OSHA says that the sound level is too loud from all those fans. These things, they're 70 decibels. They're basically about as loud as an aquarium pump. And they can cool, a tub maybe the size of half of a bathtub, that you can cool 300,000 watts into a thing that size using immersion cooling. It's full of lots of interesting technological innovation yet to be done, but it is my opinion that it will likely be the data center of the second half of the decade. It will have certain types of distributed power distribution on the thing. It will have next generation GPUs. NVIDIA, AMD, and a few other companies are working on those already. It'll be full immersion cooled. It'll have lots of fiber optic interconnect. It'll be physically compact, and it'll cost tens of millions of dollars per each of those tanks. You need quite a few of them in your data center. So that's what the human race's collective brain is likely to look like at the end of the decade. And it's somewhat different mechanically than today's data center. But really what it is a bunch of processors that know how to plunk digital numbers out of memory, do things to them, put them back into memory, and repeat trillions of times per second. That's what it's about. And that's what AI is going to need in abundance.
Well, I'm glad you're thinking through this, because I see it, and it gives me hope, because we have to succeed. We have to succeed at it.
I think so.
Delivery of a solution, but it requires organizations like OMG and to help sort of define that, to create those standards, so I can trust it, so I feel good about it.
Yep, we want it to be trustworthy, we want it to be sustainable, we want it to be reasonably affordable, we want it to be future-proof, we want there to be lots of capabilities that lots of people will find interesting for lots of different sets of applications. And I think that OMG is in a position to work on all of those fronts.
Easily. Hey, you come to this event, man, my goodness.
Yeah.
You got yourself a lot of A lot of intellectual horsepower roaming around here.
Excellent.
Yeah. How do people get a hold of you, Chuck?
Well, you can certainly find me at Byers, B-Y-E-R-S, at omg.org. And I'd be happy to help you if you're interested in joining the consortium or talking more about AI and where the future is heading us.
Cool.
Excellent. Thank you, Scott.
Yeah.
Much appreciated.
All right, we're going to have all the contact information for Chuck out on Industrial Talk. You got to check out his other conversations he's had on Industrial Talk. He's every bit as impressive back then, too. He's learned a lot in that short period of time. I'm always amazed at how the conversation just changes so drastically. Just so drastically.
It's the way technology's moving, man. Nothing's standing still, and we are really we're in the golden age.
We are. And I'm an old guy now, so I don't like it. All right. We're broadcasting from OMG's Q1 Meeting here in Reston, Virginia. You got to get engaged. Go out to omg.org. Find out more. We're going to be right back.
You're listening to the Industrial Talk Podcast Network.
Another incredible conversation delivered to you by Chuck. It is an exciting time in technology and innovation. It is. You just need to educate as much as you possibly can. Listen to Chuck. Go out to Industrial Talk. Find all his conversations because you're going to be better off. Always wonderful. OMG. That was the OMG quarterly meeting. And again, I can't stress the amount of individuals that just go to that event and just truly would like to help. It's a great event, great organization. Find out more. All right, we're building a platform dedicated to you industrial professionals. You have a podcast, you have technology, you need to put it out in Industrial Talk. Let's get some traction for you. Let's do that. All right. I say it all the time. Be bold, be brave, dare greatly. Hang out with people like Chuck, and you will be changing the world. We're going to have another great conversation shortly, so stay tuned.